the proof of some elementary functions. In this video, we are dealing with the proof of some elementary functions. Okay. First one, the Laplace transform of 1 is equal to 1 by s. Now we can prove this. For that, consider the right hand side proof. Laplace transform of 1. We know that the Laplace transform of f of t is integral from 0 to infinity e raised to minus st f of t dt. By using this, we can write the Laplace transform of 1 as integral from 0 to infinity e raised to minus st into, in the place of f of t we have 1. Therefore 1 into dt. Again this is equal to integral from 0 to infinity e raised to minus st dt. We know that integral e raised to ax dx equal to e raised to ax by the derivative of ax, that is a. Therefore, here we can use that property e raised to minus st by the derivative of minus st with respect to t, that is minus s. Now we are applying the limit which extends from 0 to infinity. We know that minus 1 by s is a constant. Now applying the limit to t only. This e raised to minus s into infinity is e raised to minus infinity. Then minus, then applying the lower limit we get e raised to minus 0. Okay, then what is e raised to minus infinity? E raised to minus infinity is 1 by e raised to infinity, and e raised to infinity is infinity, therefore 1 by infinity that tends to 0 or becomes equal to 0. Therefore we have minus 1 by s into 0 minus. Then what is e raised to minus 0? It is 1 by e raised to 0. Then what is e raised to 0? 1. Therefore it becomes equal to 1. Therefore minus 1. Minus 1 by s into minus 1 becomes equal to 1 by s, which gives the proof of the elementary function, that is Laplace transform of 1 is equal to 1 by s. Now the Laplace transform of the second elementary function, that is t raised to n. Laplace transform of t raised to n is equal to n factorial by s raised to n plus 1. Now we have the proof. Consider the right hand side, that is Laplace transform of t raised to n, and which is equal to, by using the definition we have e raised to minus st. In the place of f of t we have t raised to n dt. Now we can substitute for on putting st equal to x. By using substitution method, we can put st is equal to x, so that t equal to x by s. So we have dt is equal to 1 by s is a constant into dx. Therefore, in the place of st we can write x, in the place of t we can write x by s, and in the place of dt we can write 1 by s into dx. Therefore again rewriting, we will get 1 by s raised to n, 1 by s becomes 1 by s raised to n plus 1. We can take it outside, integral from 0 to infinity e raised to minus x, x raised to n dx. Again, by using gamma function, we can write integral from 0 to infinity e raised to minus x, x raised to n minus 1 dx as gamma of n. The representation is like this, gamma of n, and it is equal to integral from 0 to infinity e raised to minus x, x raised to n minus 1 dx. Therefore, by using that gamma function, Integral from 0 to infinity e raised to minus x raised to n dx can be written as gamma of n plus 1. Okay. Now, since here n is a positive integer, this gamma of n plus 1 can be written as n factorial. Therefore, by using that property, we can rewrite this as n factorial by s raised to n plus 1. Therefore, Laplace transform of t raised to n becomes equal to n factorial by s raised to n plus 1. Now the third elementary function, that is Laplace transform of e raised to 8s 1 by s minus a. Now the proof. For that, consider the left hand side, that is Laplace transform of e raised to 8t, and which is equal to, by using the formula we have, e raised to minus integral from 0 to infinity e raised to minus st e raised to 8t dt. Again, this e raised to m into e raised to n can be written as e raised to m plus n. By using that formula, we can write e raised to minus st into e raised to 8t as e raised to minus st plus 8t into dt, which is again equal to integral from 0 to infinity e raised to minus of s minus a of t. This first term is minus st, then second term is plus at. Okay, into dt. We know that again integral e raised to ax dx is e raised to ax by a. Using the similar property we have on integrating, we get this as e raised to minus s minus at by minus of s minus a. Now applying the limits, that is from 0 to infinity. Okay, then taking minus 1 by s minus a outside, this is a constant. Now applying the limits to upper limit, that is infinity to t, we get minus s minus of s minus a into infinity, that is minus infinity. Then before applying lower limits, we will put minus sign, then applying the lower limit 0 to t, because we are integrating with respect to t. Therefore, here we have e raised to minus of s minus a into 0 is minus 0. As we discussed in the previous, e raised to minus infinity is 0 and e raised to minus 0 is 1. Again, this can be written as minus 1 by s minus a into 0 minus 1. Minus 1 by s minus a into minus 1 becomes equal to 1 by s minus a. Here that means the Laplace transform of e raised to 8t is 1 by s minus a.